Okay, in this video we're going to explain which of the following transformation changes this function to this function. Okay, in order to understand better the answer, I'm going to proceed how to graph. Okay, so the first thing, as I said before, I'm going to graph them. So first function is this one, x cubed, and the first thing that I'm going to find out is which is the cut with x, so it means when y is 0. So I put, instead of f of x, which is y, I'm going to put 0. So I'm going to solve by x, so I can elevate both sides by 1 over 3 in order to cancel out the 3, and we have the x equal to 0. So in this part we have the cross to the axis is going to be 0, 0. So we already know for both, for not only but for x but also for y. So I'm going to find out which are the increasing intervals of this function or decreasing. In this case, I need to figure out this with the first derivative. So the first derivative is the f prime, which is going to be 3x2. You know that 3 goes down and 3 minus 1 is 2. And if you notice, always for all the values of x, this value is going to be larger or equal to 0. What does it mean? It means that this is a function that always increases. It always increases. Okay, so the second part I'm going to do is about the maximum and minimum. We are going to find out if this function has maximum or minimums. So how do you find out? You're going to find the derivative, the first derivative is equal to 0. In this case, we know that the first derivative is 3x2, so I'm going to make equal to 0, and in this point I can divide both sides by 3. I can elevate both sides by 1 over 2 in order to cancel out the square, and we have x equals 0. But we know this is a maximum or minimum local. It depends on the position you see y, because if you notice, even 0 is like when the first derivative is equal to 0. We know that, for example, when there is x equal to 5, it's going to be larger than this, and when x is smaller than x, is smaller than x, so like minus 2, going to be minus 8, so it's going to be smaller. So it depends of the point that you see, but it could be a maximum or minimal local, just locally. So the other thing that we are interested in is about the inflection points. The inflection points means when the concavity changes. When maybe it's convex, it changes to concave, and so on and so forth. So we have here is going to be the second derivative, so I'm going to make equal to 0. So we know that the first derivative is this one, and the second derivative is going to be this. 2 goes down, multiply 3, and 2 minus 1 is 1. I'm going to make equal to 0. I can divide both sides by 6, and I have x equal to 0. So in this point, when x is equal to 0 and y equal to 0, it changed the concavity. Okay, and afterwards I'm going to see the concavity of this function. So when the double prime, so the second derivative, is larger than 0, I'm going to say that this function is convex. So if you see here, so just when x, in this case we know this is the second derivative, so when x is positive, this is going to be positive. So when x is positive, this function is going to be convex. On the other side, when we have f prime prime x, which is this one, and when x is smaller than x, we know that f prime prime x, so the second derivative x, is going to be smaller than 0. So in this case, it's going to be concave. So the conclusion, what we have, like in a summary, we have the cut, which is 0, 0. We know that this point is going to be considered as a minimum or maximum local. This is a complete increase function for all this domain. The domain is all the numbers, and the range is going to be all the numbers as well. And x, when x is larger than 0, is going to be convex, and when x is smaller than 0 is going to be concave. So how do I graph that? So remember, this is the information that I already said. So the first thing we have here, that when it is smaller than 0, this is going to be concave. But when the function arrives here, it changes concavity and it goes to be convex. Okay, it's going to be convex here. So now I'm going to do the same with the g function. So we know g function is this one, so I'm going to find out the cut with x and y. So we know when x, the cut with x is when y is equal to 0, so it's going to be 0 equal to this. So I can divide both sides by 4, and after I can elevate both sides by 1/3, and in this case I'm going to have x plus 2 equal to 0, which is equal to x equal to sorry, minus 2. So we have this is the first cut, minus 2 0, sorry again, and we have the cut with y, which is when x is equal to 0. So instead of putting x, I'm going to put x equal to 0. So I'm going to have y equal to 32. So the second cut is when when x is 0, y is going to be 32. So I'm going to figure out where it's increasing or decreasing. So this is the first derivative. 3 times 4 is 11, and 3 minus 1 is this one. And remember that we have to make the internal derivative, which is going to be of x, which is 1. So it's going to be okay. So the first derivative of this one, if you see this is squared, so it means that every x you put here is going to be positive. So this means that for all the domain, the g is going to be increasing function. So we're going to figure out about the maximum of minimum. So it's going to be when x prime x j prime of x is equal to 0, and we know that x g prime is this one, and equal to 0. I'm going to just solve for x, can divide both sides by 12. I can elevate both sides by 1/2. It's going to be 0 elevated 1/2 as well, but it's 0. It's going to be x equal to minus 2. It's going to be minus 2 0, but we know that is a maximum or minimum local. Okay, because if you take one number after minus 2, it's going to be larger than this, and if you take one number less than the minus 2, is going to be smaller as well. So afterwards we're going to figure out the inflection points. So when g second derivative is equal to 0, so we know this is the first derivative form, and when we just multiply, we have this multiplication here. This the second derivative is 2 times 12, and 2 minus 1 is going to be just 1. And in this side we have this multiplied by 2, and when we replace for x, this 48 go to the other side with minus, and this is multiplied 24 is going to be divided, and when I divide both, I have minus 2. So the point minus 2, remember that is minus 2 0, is going to be my inflection point. It means that at this point it changes the concavity. Okay, so now I'm going to see when the g second derivative is larger than 0, I'm going to see it's convex. So when we know that when we take this one, and when x is larger than minus 2, this is going to be positive. So it means that after x larger than minus 2 is going to be convex. On the other side, when we have the second derivative smaller than 0, is going to be concave. So when x is bigger than minus 2, in this case, sorry, here is is smaller, when x is smaller than -2, is going to be concave. So we have like summary, the cut, we have the minimum and maximum local. We know that this increasing function, the domain is all the numbers, the range as well. When x is larger than -2 is convex, when x is smaller than -2 is concave. So now how we represent this? So we know that this is f of x. Those all the information necessary to graph our other function. So this is going to be again, it's going to be this concave, and this part is going to be convex. Okay, which is important here? As you know, when it's 0, it's going to be 32, and because it's times 4, this function grows faster. What does it mean? Well, for example, when I have just 1, for fx it's going to be 1, but for 1 is going to be 1 plus 2 is 3. Okay, and 3 times 3 is going to be 3 times 3 is going to be 3 times 3 9 times 3 27 times 4 is gonna be more than 100. Okay, so in this case this g of x grows faster, so for this reason pass here and grows faster. Okay, so what is the conclusion? Which is the following transformation changes? So this is the answer. The function fx is stretched, as you see, is stretched and shifted to the right 2 units. If you see 2, it's going to be 2 units shifted, and it's going to be stretched. So this is the conclusion. I hope it has worked. Have a great time. See you in the next video.